Imagine the powerful urge to engage in a behavior that you know is harmful, yet you can't stop. This is the reality for many individuals struggling with addiction, where the brain is rewired to prioritize short-term rewards over long-term well-being. Understanding how addiction alters the brain is crucial not only for developing empathy towards individuals who are struggling, but also for shaping effective treatment and recovery methods in society. As a psych student, I have researched addiction's neurological effects through peer-reviewed journals and scientific studies to provide a comprehensive understanding of the topic. Addiction fundamentally alters the brain's reward system, impairs decision-making processes, and leads to long-term structural changes, making recovery a complex and challenging journey. First, we'll look at how addiction hijacks the brain's reward system by overstimulating dopamine pathways. Then, we'll examine how chronic substance use impairs decision-making by affecting the prefrontal cortex. Finally, we'll explore how long-term addiction leads to lasting structural changes in the brain. Now that we understand the significance of addiction, let's start by examining how addiction hijacks the brain's reward system by overstimulating dopamine pathways. Understanding how addiction affects the brain's reward system can help us recognize why addiction is so difficult to overcome and why treatment often requires addressing the brain's chemistry. Addictive substances increase dopamine's release in the brain's reward circuits, reinforcing the behavior and making it hard to quit. According to the National Institute on Drug Abuse in 2022, drugs like cocaine and opioids increase dopamine levels, creating a rush of euphoria that reinforces the behavior, making it difficult for individuals to stop. The overstimulation of dopamine circuits can lead to a cycle where the brain craves more of the substance to achieve the same pleasurable feeling, further deepening addiction. Dopamine dysregulation is also linked to impulsive behaviors and a lack of self-control within individuals struggling with addiction. The National Institute on Drug Abuse in 2022 explains that repeated overstimulation of the brain's dopamine pathways decreases the brain's ability to regulate dopamine levels, leading to cravings and addictive behavior. As a result, the brain becomes less responsive to natural rewards like food and social interaction, increasing the reliance on the addictive substances to feel pleasure. Now that we've discussed how addiction hijacks the brain's reward system, let's focus on how chronic substance use impairs decision-making by affecting the prefrontal cortex. By understanding the prefrontal cortex, we can better understand why addicts struggle with making rational decisions and controlling their impulses, which complicates the recovery process. The prefrontal cortex, I forgot to change slide. The prefrontal cortex, responsible for decision-making and impulse control, is compromised with substance use. The National Institute on Alcohol Abuse and Alcoholism in 2021 reports that alcohol and drugs can damage the prefrontal cortex, impairing judgment and reducing the ability to make thoughtful decisions. This impairment leads to risky behaviors and the continuation of addiction despite negative consequences such as health problems or damaged relationships. Brain plasticity in the prefrontal cortex makes recovery from addictions possible but difficult. The National Institute on Alcohol Abuse and Alcoholism in 2021 explains that while the prefrontal cortex can recover with proper treatment, the changes are often slow, and recovery can be complicated by ongoing substance use. Treatment programs that focus on cognitive and behavioral therapy aim to retrain the prefrontal cortex, helping individuals regain control over their impulses and decisions. Now that we've discussed how addiction impairs decision-making, let's focus how long-term addiction leads to lasting changes in the brain. Understanding the long-term effects of addiction on the brain helps us see why recovery is not just about quitting substances, but about helping the brain heal and function properly again. Addiction leads to changes in the brain structure, such as reduced gray matter, volume, and altered neural connections. According to the Loma Linda University Health in 2022, substances like alcohol and drugs can reduce gray matter volume in areas of the brain responsible for memory, learning, and executive function. These structural changes can lead to cognitive deficits, including memory loss, difficulty learning new information, and problems with reasoning. Structural changes in the brain affect behavior, leading to impulsivity, difficulty in regulating emotions, and increased likelihood in relapse. Loma Linda University Health in 2022 stated that the long-term effects of addiction on the brain led to emotional dysregulation and an inability to respond appropriately to stress or challenges. These behavioral changes can make it challenging for individuals to maintain sobriety and rebuild their lives as they continue to struggle with emotional and cognitive issues. Now that we've explored how addiction affects the brain's reward system, decision-making, and structure, let's review the key takeaways from today's discussion. Ultimately, addiction fundamentally alters the brain's reward system, impairs decision-making processes, and leads to long-term structural changes, making recovery a complex and challenging journey. First, addiction hijacks the brain's reward system by overstimulating the dopamine pathways. Second, chronic substance use impairs decision-making by affecting the prefrontal cortex. Finally, long-term addiction leads to lasting structural changes in the brain's by impacting behavior and cognition. Understanding the neurological effects of addiction is essential for creating more effective treatment strategies and fostering empathy for those struggling with addiction. As we gain a deeper understanding of these challenges, we can better support individuals on their path to sobriety.